So today is our second day of solving systems of linear equations by substitution. So you should already have these steps in your notes, but if you don't, make sure that you copy them down. So how to solve a system of linear equations by substitution. Step 1 is to solve one of the equations for one of the variables. Step 2 is to substitute the expression from step 1 into the other equations and solve for the other variable. And step 3 is to substitute the value from step 2 into one of the original equations and solve. So if we look at example 1a, it says solve the system of linear equations by substitution. And our system is negative x plus y equals 3 and 3x plus y equals negative 1. So step 1 tells us that we need to solve one of the equations for one of the variables. And you have some freedom here. You don't have to solve for the same variable every time. You can do whichever one you want. But I would say it's usually easiest to pick a variable, if possible, that has a coefficient of 1. So like y has a coefficient of 1, this y has a coefficient of 1. This one is negative 1, so that wouldn't be too bad. But I think for a, we're going to solve one of the equations for y. So like I said, you can pick whichever one or whichever equation that you want. I'm going to solve the first equation for y. So if I want to solve the first equation, I'm just going to copy it down one more time. Negative x plus y equals 3. And if I want to solve this equation for y, I need to get y by itself. So right now there's a negative x that's being added to y. So to undo this negative x, I'm going to add x to both sides. And then negative x and positive x or plus x cancel out. I can bring down the y equals, and then y equals 3 plus x or x plus 3. It doesn't matter which order you write it in. So now I have one of the equations solved for one of the variables. This equation is solved for y. So if I'm saying that y is equal to 3 plus x, I'm going to take that 3 plus x and substitute it into the other equation where y is. So you can't plug it back into the same equation. You need to plug it into the other equation. So I'm going to rewrite this equation up here just so we can kind of see how it's getting substituted in. So that second equation is 3x plus y equals negative 1. And we just said we were going to substitute in this 3 plus x where y is, because we just found out that y is equal to 3 plus x. So we can substitute 3 plus x in for y. So my new equation with the 3 plus x substituted in, I'm going to bring down the 3x, and then instead of plus y, it's going to be plus 3 plus x. And then equals, that negative 1 is still up here. And when the coefficient of y is 1, you don't really need to like put the parentheses there, but sometimes it's helpful to see that this 3 plus x is genuinely just replacing the y because we're saying that y is equal to that. So there's no number in front of my parentheses or anything that I need to distribute. So I can just take these parentheses off and rewrite the equation 3x plus 3 plus x equals negative 1. And then from there I can combine like terms. So like terms have the same variable to the same exponent. So 3x plus x. So if I add 3x plus x, I just need to add the coefficients. This is a 1x. So 3x plus 1x becomes 4x. And then I'm going to bring down this plus 3 equals negative 1. And then now I want to get everything away from the x. So I have all my x's together. I want to solve for x, so I need to isolate it. So I have a 4 that's being multiplied by x and a 3 that's being added. So I'm going to undo the addition first. I'm going to subtract 3 from both sides. So I'll bring down the 4x. Positive 3 and negative 3 cancel out. Negative 1. Minus 3. So I'm starting at negative 1 and then I'm going down 3 more. So I end up at negative 4. So my new equation is 4x equals negative 4. And the last thing I need to do to isolate x is to undo multiplying by 4. So I'm going to divide both sides by 4 in order to undo the multiplication. So multiplying by 4 and dividing by 4 cancels out. I'm left with x equals Negative 4 divided by positive 4 becomes negative 1. So we found our first variable. So we found out x equals negative 1. So to solve for y, we're going to take that x equals negative 1 and substitute into one of the original equations to solve for y. So it doesn't matter which one you choose. You can pick the first one or the second one. If you pick the first one, just make sure you pay attention to that this is negative and this is negative. So we'll use the first one just to talk about the double negative one more time. So I'm going to rewrite the first equation. Negative x plus y equals 3. And then if I'm saying that x is equal to negative 1, that negative 1 will get substituted into the equation where x is. So I have this negative out in front, so that negative stays there, and then x is negative 1. So this turns into negative 1 plus y equals 3. And then now I need to simplify this equation to solve for y. So a double negative, or negative 1, turns into plus positive 1. So 1 plus y equals 3 is my new equation, because negative 1 is actually positive 1. This is kind of like saying the opposite of negative 1. So 1 plus y equals 3, and then if I want to isolate y, I have a 1 that's being added to y, so I'm going to undo it by subtracting 1 from both sides. And then 1 minus 1 cancels out. I can bring down the y equals, and then 3 minus 1 is 2. So we end up with x equals negative 1 and y equals 2. And then we just need to make sure that we write our final solution as a point. So x comma y, negative 1 comma 2. So the next example, example B. So x plus y equals negative 2 is our first equation, and negative 3x plus y equals 6 is our second equation. So the first example, we solved for y. You don't always have to solve for y. You can solve for x. You can solve for whichever variable you feel like is easiest for you to isolate. So with example B, I'm looking for, if I have it, I'm looking for a variable that has a coefficient of 1. So like this x has a coefficient of 1, I can solve for that pretty easily. So does this y, and so does this y. So I could either solve the second equation for this y, or I can solve the first equation for either of the two variables, because they all have a coefficient of 1. So that makes it a little bit easier. So I'm going to solve the first equation for x. So I'm going to rewrite the first equation. So x plus y equals negative 2. And I'm just doing this just to show that you can solve for whatever variable you want. You don't always have to do y. So x plus y equals negative 2. If I want to solve for x, I have to undo this plus y. So I'm going to subtract y from both sides. So the y minus y cancels out. I'm going to bring down the x, and then I have equals. I can either write it as negative 2 minus y or negative y minus 2. It doesn't really make a difference here. So x equals negative 2 minus y. So if I'm saying that x is equal to negative 2 minus y, I'm going to take that part of the equation, the negative 2 minus y, and substitute it into the other equation, the second equation, where x is. So we have to make sure that we're not substituting it back into the same one, but we're using the other equation here. So I'm going to rewrite this the second equation, negative 3x plus y equals 6. And this negative 2y is going to go in where x was. So instead of negative 3x, it's negative 3 times negative 2 minus y. And then I have this plus y right here, so plus y. And then equals 6. So the only thing that's changing about this equation, the negative 3x plus y equals 6, is the fact that instead of x, we're substituting in negative 2y minus y. Everything else stays the same. The plus y and the equals 6, those all stay the same. And then now I have an equation that just has y's, so I can solve for y, but I have to make sure I distribute, or not distribute, but simplify the left side of my equation first by distributing. So when I distribute this -3, I have to be careful with my signs. So -3 times a -2, that becomes +6. And then -3 times a -y, that becomes +3y. And then I'll bring down this plus y equals 6. So now I have some like terms I can combine. I can combine the 3y and the y, because they both have y to the first power. So I'll bring down this 6. 3y plus y turns into 4y equals 6. Now I have 6 plus 4y equals 6. I want to get y by itself, so I have a 6 that's being added, a 4 that's being multiplied by the y. So I'm going to undo the addition first. In order to undo the +6, I'm going to subtract 6 from both sides. So 6 minus 6 cancels out. I have 4y equals 6 minus 6. That kind of also cancels out, but since it's on this side, the other side of the equal sign, we'll want to write 0 there, because we can't just have nothing on that side of the equal sign. So now we have 4y equals 0. In order to undo multiplying by 4, I'm going to divide both sides by 4. So 4 divided by 4 cancels out. I'm left with y equals 0 divided by 4 is 0. 0 divided by anything is still 0. So we figured out that y equals 0. I now need to figure out what x is. So to figure out what x is, I can take that y equals 0 and substitute it into one of the original equations where y was. Or sorry, y equals 0 goes into one of the original equations where y was to solve for x. Doesn't matter which equation you pick, I'm going to use the first one. So I'm going to rewrite it up here. X plus y equals -2. 0 is going to go in for y, and we'll solve for x. So instead of x plus y, it turns into x plus 0 equals -2. And then x plus 0 is just x equals -2. So we got y equals 0 and x equals -2. We just need to write our final answer as a point. So x comma y, -2, comma 0.